for the week then. Finish up the 11.4, 11.6 notes. We pretty much got through that today. Tomorrow, Chapter 11 review. Wednesday is a testing day. It's not no school, it's testing day. On Thursday, Chapter 11 review, there's area maze puzzles that are in there. So if you look in OneNote, you can see what those are. I'd spend a little bit of time looking at those. And then Friday's our Chapter 11 test. You can see your due dates for when the homework problems are going to be due. All right, so these are the answers to 11.4 homework. I'll just go ahead and start highlighting them so you can find them a little bit easier. It's not that part. There we go. So those are what we're looking for in each of these. I am recording this right now, so if you want to go back, you can pause the video and look at the work that was shown on this one, but I do want to make sure that I get through a little bit more today. So again, here are the answers for the 11.4 homework. And then let's go ahead and move on to, we're finishing up. There's a few problems in 11.5 that I'd like to go over with you. Then we'll get into 11.6. As I mentioned earlier, 11.4 to 11.6 really run together quite a bit. 11.6 is finding more areas. We did a lot of that stuff already. But 11.5 with the similar, some of these get to be a little more difficult. So I'll go ahead and find this problem in your 11.4 to 11.6 notes. All right, so similar polygons means that all the corresponding sides are in the same proportion, all the corresponding angles are equal, and then there are ratios between the areas that are a little bit different. Now, as you look at this one, it might seem like these look like two rectangles that are similar to each other, and maybe they are, but maybe they're not. We don't have enough information to know for sure. AC is 1, PR equals 3. And it says that AC and PR are in the same location. I don't really like the names that they gave these, ABCD. It should be ABDC and PQSR. So kind of a problem with the way they name those, but let's just suspend our disbelief for a second and say they did name them correctly. AC and PR are the ones that are in fact corresponding to each other. And so this establishes what we call our linear ratio, or I could call it the A to B ratio, which would be 1/3. The one on the left, the one on the right, all the corresponding sides are in the ratio of 1 to 3. Now, that's not just corresponding sides, it'd be corresponding diagonals, corresponding altitudes, as well as corresponding perimeters. And since the perimeter for PQRS, the perimeter for the big one over here is given to be 22.2, we can use that to find the perimeter of the small one. And that's just going to be the same ratio that we were given already. So bringing this part of it together, I could say that 1/3, this ratio between those corresponding sides, is equal to the perimeter of this ABDC divided by the perimeter of the one on the right, 22.2. It's just a nice straight up proportion. Those ratios are going to be equal to each other. Cross multiply, then divide. So cross multiply, divide. What does the perimeter of that smaller one come out to then? 7.4. So 7.4 units. So we can find that perimeter just using that ratio we were already given. Maybe the more difficult part in this one is once we get into the area, it says the area for the small one is 2.7. So the linear ratio is this. I would then say that the area ratio are those numbers squared. Square the numerator, square the denominator, so 1/9. The area of the smaller one is 1/9 the area of the bigger one. If the area of the small one is given to be 2.7, and we're trying to find the area of the big one. Here's my proportion. 1 over 9 equals 2.7 over the area of the unknown. Cross multiply, solve for this one. And our area for the big one, what is that product? 24.3. That would be in units squared. Let's do one more, and that's going to be this number 8. Go ahead and take a look at it. I'll give you a chance to read it, see what you can set up for this one. There is no drawing given. They're just telling us that there are 2 shapes. So can you set up some proportions and see if you can solve for the 2 unknowns? As far as the perimeter goes, the perimeter of the bigger one, I got 96 inches. Is my algebra correct there? Okay. And then for the area of the smaller one, how many of you got that part of it done? Okay, so we're going to say 25 over 64. That's the ratio of the areas is equal to either A over 72 or 72 over A. Does it matter? Definitely does, right? The smaller over the bigger is what the left side looks like. So I have to take the area of the smaller divided by the area of the bigger. If you did it the other way, you'd be getting a larger area than what we wanted to for this one. So for this one, cross multiply, solve for A. Someone help me out with that number. What's that area come out to? 28.125. And just a quick check of this one. Here's my smaller shape. It has both the smaller perimeter and it has the smaller area. And that's what I'm really looking for here. So unknown area, unknown perimeter. Use your A to B and A squared to B squared ratios. All right, so there's our 11.5. go down to 11.6, which is called geometric probability. Geometric probability. And the essence of this problem comes out to, if this whole square, like in number one, if this whole square was a dartboard, and you're a good enough dartboard player to like at least hit the board every time, you know that's going to happen, but it's just going to hit randomly in there somewhere, what percent of the time is it going to land in the shaded area? The other way of asking that is, what percent of the entire object is shaded? Sometimes we can do these directly, sometimes we have to do them indirectly. So when we say percent shaded, the very general formula for that is, what is the area shaded divided by what is the total area? And that's what we're always looking for in these problems. It's a good idea to map these kind of problems out, write out what you're talking about in the numerator, what's represented in the denominator. Sometimes they're direct, sometimes they're indirect. Percent shaded is area shaded over area total. That's what it's always going to be. Interesting thing in number one is we don't have any numbers, but that's okay. This is one of those problems where it doesn't tell us what that shape is, but the outer shape is in fact a square. And I'm trying to be consistent with what I've seen in other places. This is a square this time. Like we weren't given that, but it is going to be a square. I can pick whatever number I want, because this shape that I have on my computer screen right now, compared to the one that's on your computer screen, that's on my computer screen now, or that's there now, they're all going to be similar to each other. So the percent shaded is going to be the same regardless. The shaded area would be different, the total area would be different, but those moving up and down with each other. So it doesn't matter what number we choose, we get to pick. Some numbers, quite frankly, are just better than other numbers. I'm probably not going to choose a number like 3 square root of 7 for that length. Like I could, and I get an answer, and I get an answer to be correct, but I'm making my algebra more difficult than it needs to be. I want to pick a friendly number. So what do I mean by a friendly number? It's a very generic term. Usually I want a number that's even. I can divide it by 2. Usually I want a number that's probably divisible by 3 if I can, because sometimes if I have like a 30, 60, 90 triangle, I divide by root 3, and it'd be nice to be able to keep, like again, keep fractions out of it if possible. So having a number of 2 is good. Sometimes a number like 6 would be good. Sometimes if I go bigger like 12, then it's even divisible by 4, which is good as well. But as I get in bigger and bigger numbers, then all of a sudden my arithmetic, I have to, use bigger numbers. I don't necessarily like that. But you can pick a number that you think makes sense to you. And I'm going to go with a 2. He said, well, didn't you say divisible by 3? In this one, there is no 30, 60, 90 triangle. So I'm not worried about the 3. I'm just going to divide it, like make that length 2. Now that that's been chosen, I'm going to say that the percent shaded is equal to area shaded divided by area total. I think it's a good idea to get in the habit of maybe not writing this part of it down, but at least writing this next part that I have as a fraction. What is represented by the total area? It's the area of the square. I can write area of square. I can do A with a little subscript square after that. This shows me what's going on in the denominator. And in the numerator, I want you to turn to your friend, what is the shaded area this time? What's represented by the shaded area? This is one of those indirect ones. It's not just the square. It's not just the circle. Isn't it square minus circle? And so I really think it's important to give yourself like a blueprint for what you're doing these problems. And this would be a good way to start formatting these, is at least start with this. Show me what it is you're working with that you're trying to find. Now we can do some calculations. Based off of the nice number that I chose, what is the area of the square? Minus. What is the area of the circle? And here's why I chose that to be a 2 rather than a 1. If 2 is the length of each side of the square, then what is that for the circle? 1. 1 is the radius, right? So what's the area of that circle? Exactly. Pi. Pi times 1 squared, so pi divided by, what's the area of the square? 4. So by choosing this number, we have this percent shaded. What does this represent? This is the exact area, or excuse me, the exact percent shaded. Like we've seen with some other exact answers, it's a bit abstract. You're saying this is a percent. Yes, it is a percent as an exact value that doesn't have a decimal attached to it yet. That's kind of hard to understand. So we're going to make it more understandable with one of those concrete numbers. In other words, go to your calculator, take 4 minus pi divided by 4, either put numerators in the parentheses or do alpha y equals, do the numerator over denominator. Do it in a way so that you're dividing that whole numerator by 4. If you just did 4 minus pi divided by 4 like that, that wouldn't give you the correct answer. Take pi divided by 4 and then 4 minus that with order of operations. So this is not what you would want to put into your calculator. Your answer should come out to a decimal point something, something, something. We're going to go to put it into percent form. So Annie, what'd you get for your decimal?
0.215.
Give me a few more. 215. 4601. Okay, so now we're going to bring it to the right. So 1, 2 places, 21.460. We'll go to 3 decimal places. And there's our percent. The reason why I'm having you go to 3 decimal places is because eventually, like for AP exams and stuff, they have you go to 3 decimal places in math. So just making that a characteristic for you now. There's our exact and concrete percent shaded for this one. An idea in percent shaded is area shaded divided by area total. Give yourself some kind of blueprint. Number 2 might be the exception in that, and you're looking at it saying, well, where is the percent shaded? Is this 0? Nothing is shaded. This is one of those examples where it didn't print off very well, but here is our shaded region in gray. So if I'm looking at the percent shaded in this one, it would be the area of that sector, and we can find that sector directly actually, divided by the area of the entire circle. That would be my idea. And if this were a harder problem, I'd do a lot of calculations, I'd put a number in there and so forth, but this one can be done a lot quicker than that. I've told you I don't want you to just be a formula person. This would be using a formula to go about it formulaically. I want you to logic your way through this one. What percent of this entire shape is shaded? Turn to your friend. Can you figure that part of it out? Not drawn to scale, FYI. Go. All right, ready? Now, as you're going through like some of the formulas here, you're saying, okay, like the area of this would be central angle, which is double the 40. Good job. Inscribed to central, you double that. 80 over 360 times pi r squared divided by pi r squared. Well, those pi r squareds would cancel each other out. And the way that we got the area of a sector is we said this is a fraction of the entire circle anyways. So wouldn't the percent shaded be 80 over 360? Divide by 10, divide by 4. And I'm looking at 2/9. 2/9 of this is shaded. That is an exact percent or exact percent shaded. And then to get a concrete, take 2 divided by 9. And I believe that's 22.222%. So sometimes I don't want to overcomplicate it. I don't want to make it any harder than I need to. In this case, it's 2/9. Number 3, what kind of shape do we have? A rectangle. We have a diagonal. Then there's a triangle that's shaded. Question is, what percent of this one is shaded? Now, I could go through it. Area shaded divided by area total. It's the area of the triangle divided by the area of the rectangle. What percent of this one is shaded? Don't overcomplicate it. 50% is exact and it is concrete, both 50%. Another one didn't copy great. Here is the shaded region. The goal is to figure out the percent shaded in this one. You're given two numbers. There's a 6 and there's an 8. This problem gets to be a little bit more difficult. I'm stuck. Okay, so my idea, the percent shaded is the area shaded over area total. In other words, what's going to go up in the numerator? What is the shaded area? The area of just the rectangle. We can do that one directly. I don't have to subtract anything. Divided by, what's the total area? It's the area of the triangle. So there is my general idea. If I can find the area of the rectangle and I can find the area of the triangle, I divide them, then I have my percent shaded. Now, some markings that are in here that might seem a little bit hidden. It does say that this yellow segment is equal to that yellow segment. So this top triangle is isosceles. But the other thing that maybe looks a little hidden is that this length down here also has a 1 hash mark on it. So this length is also the same. So not only is this an isosceles triangle at the top, it's got to be an equilateral triangle. So use that to help guide you. Some of the observations I saw as I walked around. 6, 2, good observation. And with this being an equilateral triangle up top, that means that these angles are 60 degrees each. And with this being a rectangle with the perpendiculars there, it means that this segment and this bottom segment are parallel to each other. Parallel, parallel, transversal. So what that means for us then is that this has to be 60 degrees also. And that opens up a lot in, for instance, this green triangle. This green triangle, this green 30, 60, 90 triangle, where 2 is the hypotenuse. 2 is the hypotenuse. What do you do to go from hypotenuse to short leg? Divide by 2. So this little length is 1. And with all this symmetry in here, this left side would be 1 as well. So across the bottom, we have 1, 6, 1, which adds up to 8. The whole triangle is an equilateral triangle, as it should be. 60 degrees at the top, 60 degrees bottom right, 60 degrees bottom left for the same reason. So if the short leg is 1, you need to go to the long leg in the 30, 60, 90, which means you're getting bigger. You multiply by √3. Then you can start finding the areas for those different shapes. Area of the rectangle is base times height. The area of the regular triangle is side squared root 3 over 4. Root 3 over 64 root 3 over 4. 64 over 4 would be 16 root 3. So the area of our rectangle divided by the area of our triangle. Divide numerator and denominator both by root 3. Divide them both by 2, and we get 3/8. 3/8 of this shape is shaded. If I take 3 divided by 8, it comes out to a nice exact percent. So if I wrote down 37.5%, that is both exact and concrete. If I wrote 3/8 also, there's nothing wrong with that, but this covers both exact and concrete answer without having to round. So 30, 60, 90 triangle kind of snuck in there. All right, so in this one, we're trying to figure out the percent shaded, and that's going to be represented by the entire shape, which is the area of the triangle. So there's our denominator. The numerator is indirect, area of the triangle minus the area of the circle. So here's our general idea of what we need. Problem is there's no number associated with any of these, so we're going to have to insert a number. And I can use whatever number I want. I can insert it wherever I want. There are some good places to put it, some bad places to put it that weren't going to be as helpful. And again, I want to choose a number that I think is going to make sense. So what I'm going to do is draw in this segment perpendicular down, and that blue segment is significant for a couple of reasons. One, it is the radius of the circle, so it's significant because of that, and because it's a regular triangle, the name given to the segment that goes from the exact center of a regular polygon perpendicular to one of the sides is also called the apothem. So it's the apothem for the irregular triangle, so it's significant to that one as well. I can make that length whatever I want it to be. Again, I'm going to choose a number that I think makes sense. I'm seeing 30, 60, 90 triangle in here, so maybe I'm going to have to divide by a 3. Maybe I'm going to have to divide by a 2. I'm going to call the length 6. That's probably bigger than it needs to be. I probably could call it just a 1 or a 2, but I'm going to call it 6 just in case. And if this length is 6, then when I draw in this red segment, I should be able to figure that length out. Question is how? It's focusing on this yellow triangle that was created. The whole triangle was an equilateral triangle, so each angle was 60 degrees, 60 degrees. But when we drew in this radius of the triangle, it's going to bisect that 60-degree angle, making it just a 30-degree angle down there. So now we have a 30, 60, 90 triangle here. Have to pay attention to where the numbers are at. This 6, this is going to be the short leg, so this one is the key. To get from there to the long leg across the bottom, we get bigger, so we would call this 6 root 3. Or the entire length, well, would be 12 root 3. And now with these numbers, see if you can figure out the area of the triangle and the area of the circle. It is a regular triangle. You have a few ways you can make that happen. There's also the most basic way, 1/2 base times height. Keep that in mind. I'm seeing for the triangle, 1/2 base of 12 root 3 times the height. The height would be this entire turquoise segment. What would that entire height be? Anybody know? because of all the symmetry involved in this center of the circle is the center of the regular triangle. When I say the center, it is the center, the incenter, the orthocenter, the circumcenter, the centroid. It is the everything. So if this bottom part is 6, the top part has to be 12. So what is the entire height here then? 18. So I believe that triangle then is going to come out to 108 root 3. 108 root 3. 108 square root of 3 minus the area of the circle, which is 36 pi. And I do have some pretty big numbers in here. That's based off of the fact that I chose this radius to be 6. If I had chosen a smaller number, I'd have smaller numbers in here. And I do want this to be in simplest form. So I have to look at these 1, 2, 3 terms and say, what can be divided by all of them? Very often, my choice of numbers right here is going to influence those. So my guess is that they can all be divided by 6, maybe even more than that, but I can divide them all by 6. So (18√3) minus 6 pi over 18√3. So there's a start. Turns out I can divide them by 6 again. So then 3√3 minus pi over 3√3. So there is an exact answer. Doesn't matter what value I had started with it. Even if I had, like, if I put a 1 in here, if I put like a 10 in there, whatever I put in there, it should still simplify down to the same exact answer. So no matter what path you took, you should get there. And then go to your percent. And as I look at this, this is drawn to scale well enough. So if I got an answer like 90%, that doesn't look accurate to the drawing. And then again, the drawing is good enough that I should get an answer that makes sense. I'm thinking somewhere between maybe 20 and 40% might be a reasonable estimation based off of what I'm seeing here. And again, I could be wrong. It could be maybe a little bit less than 20. But my answer should make somewhat of sense here. Who's got that percent for us? Amelia, go ahead. 39.540. Thank you. So there is our percent shaded.